After learning how to analyze the kinetics of a reaction using the integrated rate method, you may wonder how you can tease out the effects of different reactants. So for instance, if you had a reaction such as A plus B goes to C, how would you graph the reaction to find out whether it's first or second or zeroth order in A when you don't know what the order is in B? How do you isolate those two effects? Well, one way of isolating those effects is using a trick called pseudo order. So suppose we ran the reaction where the initial concentration of A was equal to, say, 0.5 molar. And the initial concentration of B naught, was equal to 0.001 molar. So we can see that during the course of the reaction, we're going to eat up all the B and almost none of the A. In other words, the concentration of A is going to stay very close to the original concentration. We could summarize that by saying the concentration of A is approximately constant. It's approximately equal to the original value because there's so much of this that even when the reaction's over, we've only used up 1 millimolar out of that 500 millimolar that we have. So if we use a vast excess of A, we're really only going to be probing on what happens to the reaction rate as a function of the concentration of B. So we can summarize that by saying, let's say we've got V is equal to K, A to some exponent, and B to some other exponent. If we run in excess, especially a large excess of A, we can say V is equal to K observed B to the beta. And in this case, K observed is just equal to the original rate constant times the initial concentration of A. So we're just taking this, and since the concentration of A is approximately constant, which we said over here, we're just lumping this all together and calling this K observed. And that makes this rate a function of just one reactant. And so now we can graph what happens to the rate. We can graph the concentration of B as a function of time to see if it's zeroth order. If that's a linear graph, then that would be a zeroth order reaction. Or we could graph the log of the concentration of B versus time. And if that's straight, we know that it was first order in B. Or we could graph 1 over the concentration of B versus time. And if that's straight, we know it's second order in B. So we can probe on the order of the reaction in B by running it in excess A. Now similarly, we could do a whole different set of experiments where we run the reaction in excess B. Well, in this case, V would be equal to K observed times the concentration of A to whatever its exponent would be. And so now we're just probing on the concentration of A and the effect of the concentration of A on the rate, because if we run it in excess B, this time B would be approximately equal to B naught, because we have so much B that almost none of it's eaten up during the whole course of the reaction. So this is approximately constant. So maybe its concentration changes from 0.5 molar to 0.499 molar. So that's not a really big change. So effectively it's constant. So this method of choosing one component in vast excess and probing on the effect of the other, and then running it with the other one in vast excess and probing on the effect of the other one is a way to isolate the effect. Now, what do we mean by pseudo order? Okay, so for instance, in this case, if beta came out to be a 1, we'd say the reaction was pseudo first order. In other words, there's first order in the thing that we were probing on, because we were not probing on A since there was excess A. Or if this beta was a 2, we'd say the reaction was pseudo second order. Okay, because it's we've blocked out the effect of A, and so it's second order in B, and so the reaction is pseudo second order. Okay. Down here, if we had this reaction here, and I didn't write out what the K observed would be, K observed is just the original K times the concentration in B. Okay, so if this reaction was, say, second order in A, if this alpha was a 2, we'd say the reaction was pseudo second order. Okay, so basically when we talk about pseudo order, we're saying that it's second order in the thing that's actually being probed on, and we actually aren't making a statement yet about what the overall order is.